Hello. Today we are going to discuss variational method. There exist systems whose Hamiltonians are known, but they cannot solve exactly by perturbative treatment. That is, there is no closely related Hamiltonian that can be solved exactly or approximately by perturbation theory. So, one of the approximation methods that is suitable for solving such problems is the variational method, so which is also called the Rayleigh-Ridge method. The variational method is useful for determining the upper bounded state of the systems whose Hamiltonian is known, whereas its eigenvalues and eigenstates are not. It is particularly useful for determining the ground state energy. It is also useful in the treatment of chemical bonds. In variation method, one has to make some guess of the wave function, then apply the variation principle, obtain an upper bound for the ground state energy. So the basic essential idea of this method is to evaluate the expectation value of a Hamiltonian operator of the system with the to a trial wave function. So the variations principle of the ground state. So for example, if you look at in this equation, this is Schrodinger wave equation. Here the wave function psi naught is the exact ground state wave function, and E naught is the exact ground state energy. So this one is a trial wave function, which means this one is a approximate ground state wave function or trial wave function. So the expectation value of energy can be written according to both postulates of quantum mechanics like this. So in case if you want to write terms of Dirac notation, so you can use this type of notation. So the expectation value of Hamiltonian of the system, I mean this one, the, in case E pi equal to this one, okay? The expectation value of the Hamiltonian of the system. So the variation principle states that the ground state is always greater than the expectation value of the Hamiltonian. This is the uh, principle of variation. So, for example, if you take the trial function as a linear combination of the two wave functions, but we don't know that wave function exact values, so then we can write this linear combination of this wave function. Okay. So suppose if you draw a system, the graph is, for example, here the C is the adjustable parameter of the system. Energy depends upon this adjustable parameter. Suppose this graph is like this. These are the different type of approximate. So if you minimize this energy with respect to this adjustable variable, then you can get this adjustable values, then you can substitute these values into expectation value of the system. Then you can get one number. So that is the ground state energy of the system. So for example, in the variational principle, so if trial wave function is normalized, so here the expectation value of energy is there. This is expectation value of energy. Expectation value. If the trial wave function is normalized, which means this one, right? Denominator value. If it is normalized, then it's going to 1. In case in practice, the trial wave function is a selection in terms of the one or more variable parameters. So the values of expectation value is evaluated. The value of expectation value is minimized with respect to this parameter. The resultant value is the closely estimated to possible with the selected trial wave function. In case the trial wave function, if it is not normalized, then you can use this type of condition. If it is normalized, then you will get the variation principle statement. In case the tail wave function is not normalized, then you can get circular equation. So this is a derivation of this to this second case. So if it is not normalized, then you can use equation. So how you got this one equation? So expectation value of system wave function, right, this phi h sharp phi by phi. So this wave function we express in terms of linear combination, right? So if we use this one, the linear combination, this type of equationality. So if we try to minimize this equation with respect to this variable parameter, Ci is, if you minimize Ci, you can get the one circular equation. If you minimize with respect to Cj, another circular equation, you can get the total information of this. Okay. So basically, the essential uh, points of the variation principle method, we need to calculate ground state of the, for that we need to remember first one is we need to guess the trial wave. So for example, first step is we need to guess the trial wave. This is trial wave function. So this trial wave function, C1 comma, the function of adjustable variable. Okay. And second point is calculate the energy of the system. The first one you need to guess the trial wave function. So this is the guess. So here the C1 and C2 on Cn are the adjustable parameter. Second point is to calculate energy, okay, C1, C2 with respect to this guess. Okay, this is second step. Third step is minimize E naught value with respect to adjustable. Minimize this to this adjustable value, for example. Okay. This gives the value of C1 and C2 on C. And fourth step is substitute these values, adjustable parameters in the approximate. Then you can see ground state energy of this. So the variation principle states that always ground state energy greater than, ground state energy station value is always greater than the ground state energy. So from these points we can calculate ground state energy given. Problematic purpose, for example, in CSIR net take a lot of time to calculate. So you need to practice the trial wave calculate. So then it's going to. So these are the four main steps to remember. So remember this one, 4 points, and final point is in case your system is not normalized. If it is normalized, then you can this type of equation. If it's not normalized, then you can get particular. Okay. So this is all about the variation. Next class we are going to do one small example of this variation.